everyone, myself Yogita R. Today I am going to talk about OpenGL color functions, which comes under the subject computer graphics. Introduction to OpenGL color functions. OpenGL provides a powerful set of functions for working with color. These functions allow you to define and manipulate the color of graphic elements on the screen, enabling you to create stunning visual effects and realistic representations. Defining colors in OpenGL. In OpenGL, you can define colors using a variety of functions that allow you to specify the red, green, and blue RGB components of a color. These functions provide flexible ways to set the exact shade you need for your graphics. What is an OpenGL? Open Graphics Library or OpenGL is a cross-language or a language-independent cross-platform API for rendering 2D and 3D vector graphics. Use of polygons to represent images. OpenGL API is designed mostly in hardware. Design. This API is defined as a set of functions which may be called by the client program. Although functions are similar to those of C language, but it is language independent. Development. It is an evolving API and Kronos Group regularly releasing its new version having some extended feature compared to previous one. GPU vendors may also provide some additional functionality in the form of extension. Associated libraries. The earliest version is released with a companion library called OpenGL Utility Library. But since OpenGL is quite a complex process, so in order to make it easier, other libraries such as OpenGL Utility Toolkit is added, which is later superseded by FreeGlut. Later included library were GLEE, GLEW and Glidey. GL color functions. GL color 3F and GL color 4F. OpenGL provides two functions to define the current color, GL color 3F and GL color 4F. These functions allow you to specify the red, green and blue components of a color and optionally the alpha component. OpenGL color. OpenGL has a large collection of functions that can be used to specify colors for the geometry that we draw. These functions have names of the form GL color, where the star stands for a suffix that gives the number and type of the parameters. I should warn you now that for realistic 3D graphics, OpenGL has a more complicated notion of color that uses a different set of functions. You will learn about that in the next. But for now, we will stick to GL color star. For example, the function GL color 3F has three parameters of type float. The parameters give the red, green and blue components of the color as numbers in the range 0.0 to 1.0. In fact, values outside this range are allowed, even negative values. When color changes are used in computations, out of range values will be used as given. When a color actually appears on the screen, its component values are clamped to the range 0 to 1. That is, values less than 0 are changed to 0 and values greater than 1 are changed to 1. You can add a fourth component to the color by using GL color 4F. The fourth component, known as alpha, is not used in the default drawing mode, but it is possible to configure OpenGL to use it as the degree of transparency of the color. Similarly to the use of the alpha component in the 2D graphics API that we have looked at, you need two commands to turn on the transparency. GN enable GL blend and GL blend function GL src alpha, GL1 minus src alpha. This first command enables us of the alpha component. It can be disabled by calling GL disable GL blend. You need two commands to run on transparency. The first command enables use of the alpha component. It can be disabled by calling GL disable GL blend. When the GL blend option is disabled, alpha is simply ignored. The second method tells how the alpha component of a color will be used. The parameters shown here are the most common. They implement transparency in the usual way. I should note that while transparency works fine in 2D, it is much more difficult to use transparency correctly in 3D. If you would like to use integer color values in the range 0 to 255, you can use GL-color3UB or GL-color4UB to set the color. In these function names, UB is the unsigned byte. Unsigned byte is an 8-bit data type with values. Using any of these above functions sets the value of a current color which is part of the OpenGL state. When you generate a vertex with one of the GL vertex star functions, the current color is saved along with the vertex coordinates as an attribute of the vertex. We will see that vertices can have other kinds of attribute as well as the color. For example, here is a triangle in which the three vertices are assigned the color red, green and blue. This image is often used as a kind of hello world example for OpenGL. The triangle can be drawn with the commands GL begin GL triangles, GL color 3F, 100 is for red and GL vertex 2F minus 0.8, minus 0.8, GL color 3F 010 is for green and GL color 3F001 is for blue. Specifying color components. In OpenGL, you can precisely define the red, green and blue components that make up a color. This allows for a wide range of hues and shades to be represented in your 3D graphics. Clamping color values. In OpenGL, color values are typically specified as floating point numbers ranging from 0 to 1. However, certain rendering operations may result in color values outside this range. To ensure colors remain within the valid range, OpenGL provides a process called clamping. Clearing the color buffer. In OpenGL, the color buffer is where all the rendered pixels are stored. To clear the color buffer and reset all pixels to a specific color, you can use the glclear function along with the glcolor bit flag. Blending colors in OpenGL. OpenGL provides powerful tools for blending colors to create complex visual effects. By combining the colors of individual pixels, you can achieve a wide range of artistic and photorealistic results. Enabling and disabling blending. OpenGL provides the ability to blend colors together, creating transparent or semi-transparent effects. This is a powerful technique for rendering complex 3D scenes but must be carefully controlled to achieve the desired visual results. Conclusion. In this final, we will summarize the key takeaways and provide best practices for effectively using color in OpenGL applications. Proper color management is essential for creating visually stunning and cohesive graphics.